College, Mumbai in 1934 with the unique distinction of securing 100% marks in chemistry, a record of the Bombay University. He then joined UDCT, now it is ICT, in 1934 as the first batch of BSc Tech in Chemical Engineering and graduated with the distinction in 1936. Then he joined University College London, where he completed a postgraduate diploma in chemical engineer and then started his doctoral research under the guidance of Professor H.E. Watson on the drying of pigments. He got many attractive job offers in the UK, but he chose to return to the India in 1946 and joined the faculty of UDCT, that is this institute. NRK joined IIT Mumbai, that is Bombay, in March 1959 as a professor and head of the chemical engineering department, where he continued till his retirement in September 1974. At the Silver Jubilee selection of the All India Manufacturer Association in 1973, India President Sri V.V. Giri honored Professor N.R. Kamath with an award for his contribution to chemical engineering. The Color Society started organizing late Professor N.R. Kamath Memorial Lecture from 1984, that is almost 40 years completed, and the first speaker was Sri C.H. Chokshi, Chairman Asian Paints, and topic was Paint Industry 14 us today. Your presence is a testament to the strength of our community, and I am confident that together we will conduct the field of coating technology for more sustainable future. Thank you. Let us look forward to an inspiring and engaging event today. Thank you very much.
Thank you, sir. Now I would like to ask from the audience if they want to share any memory of late Professor N.R. Kamath.
Good evening, ladies and gentlemen. This will be a bit of unusual stuff because I have never seen him nor I have met the late professor. But somebody who had an opportunity to contribute and make his life outside of India, but still he chose to come back and contribute towards the growth of India, I have nothing but salute to him, kind of thing. So that's all I would say is I have high regards and appreciation for him. Thank you.
Thank you, sir. Now I would request Professor Dr. S.T. Maske to share his valuable insights.
Thank you. Good evening to you all. On behalf of Department of Polymer and Surface Engineering of ICT, I welcome you. Though Color Society has already welcomed you for this today's function, but as heading the department, it's my duty. As institute is hosted this function as an Institute of Chemical Technology, we are the integral part where we run the polymer and surface coating degree, PG, PhD. I no need to talk on the departmental academic reforms, academic credentials. But this is the event where I should mention one part is the Professor N.R. Kamath is our founder HOD and who started this department named as PPV, which is plastic paints varnishes that time. But his vision and the thought process of such, because we do visit to an many academic institution across the country. If you see it more categorically, the paints technology department of any university in the country is our oil and paints. More or less it is oil and paints if it is combined, or it is a separately as an paints technology. Whereas in UDCT that time, under the visionary person like late Dr. N.R. Kamath, Professor N.R. Kamath, who started which is plastic and paints. So rather than paints which is oil derived, oil based, so he must have been thought it at that period of time where water based paint, emulsion based paints will be took over the oil based, and then polymer and paints is a right set of amalgamation as comparison with the oil and paints. So who was our visionary torchbearer leader of the department? On his name, this late N.R. Kamath Memorial Lecture is organized, and which will be delivered by one of our close friend and the associate, nothing but an Krishnaraj, to whom I know since decades now. And it's my responsibility to talk to you on this occasion just as a department and the institute. And happy to definitely will be talked on metamorphosis of coating industry. So you will be talked about science in the coatings. And today, the good to share with you all, ICT has completed the admissions at UG, PG and PhD level, where the polymers, chemical engineering is sort of always into top-notch branches which people wants it. And the paints technology, which was at the third or fourth level of ICT's ranking wise. But Dr. Samant, to share with you, your son was a proud alma mater of this department as well. This year the surface coating is immediately next to the polymer engineering, so it was chemical engineering, polymers and surface coating, where our department is comprises of polymer and coatings in the single. So it was proud moment of every one of us, as few of our students of UG level I could see in the audience also. So must be happy to know this, and good to see you all on the
Exactly. 100% marks those days getting in BSc chemistry was just an impossible thing. Number two, you all people, everybody knows about Professor M.M. Sharma, Padma Vibhushan Professor M.M. Sharma. He is a great chemical engineer. He did his BChem from UDCT, Chemical Engineering Department. And for masters, he selected guide who was the head of PPV, Polymer Paints and Varnishes. So he did his masters under Professor Kamath in PPV. See, you have to understand, how things happen. And then today you people know about Dr. Mashelkar, CSIR chief. Then Mashelkar did under Kamath will come home, and then first he will run to the fish market. So that is how everything used to happen in case of Professor Kamath. And Professor Kamath, Dr. Mashelkar, Narayan Duldoya, who was the chairman of NOSIL those days, then R.C. Sinha, who was the chairman of Maharashtra Secretary he was. So those big league people, and now Krishnaraj is included in that big league. So
R&D leader with over 28 years of experience in paint R&D in various companies and having experience in both paints and polymer development. He is a senior R&D leader with proven track record and is someone who consistently bringing innovation in area of his work. Currently, he is heading the interior and designer finish R&D of Birla Opus Paints, which is part of the flagship Aditya Birla Group as Assistant Vice President. In his current role as AVP, he is responsible for developing new product and managing the state-of-art R&D of Birla Opus Paints, along with the leading a highly motivated team of scientists. He started his career with the Asian Paint in 1996, where he spent 14 years in developing various kinds of polymers and paint with the significant contribution in the development of interior paint and polymer emulsion. He moved to consignor-like paints and worked there for more than a decade, heading the decorative R&D and leading some of the path-breaking decorative products. He joined Birla Opus Paints in Indian and international journals for his credit. He is won the prestigious Indian Paint Association Award, that is, it was first prize in the research category for the best research paper for his work in water-based paint. Krishnaraj is voracious reader and patiently pursue his interest in books, including fascinate fiction to biographic to self-books. He is also a great speaker and have presented in many national and international forums on number of different topics in the past 2 decades. Thanks.
Hello, can you hear me at the back? Thank you, Dilip, for the very, very kind introduction. And good evening, friends. Good evening, students, my fellow industry colleagues. I'm really privileged to stand in front of this august gathering. Many of my industry friends are here. You know, I can see many of them. Many of the beloved students are there. So when Shivaji came to invite me for this lecture, I was thrilled because, you know, I generally get invigorated by the young people, right? The Gen Z is right here. The energy is contagious. So I thought that's another opportunity for me other than, celebrating Professor Kamath. So when I stand in this podium, you know, ambivalent feeling comes to my mind. I'm beaming with pride because of the very fact that this podium has witnessed and celebrated the who's and who's of the chemical industry, as Mr. Samant said right now. And also nostalgic because I have a lot of fond memories about this great institute. So every pillar in this institute has a story to tell. A story about wisdom, a story about innovation, and probably a great story about patience and perseverance. So friends, before we go to this topic of metamorphosis of coatings, it's my duty to really commemorate and remember Professor Kamath. Even though I have not privileged to meet him and learn from him, I've read about him and heard about him, and you know, a lot of inspiration we draw from Professor Kamath, as the guest people are talking about, the erudites are talking about. So Professor Kamath was a multifaceted person. He was not just a teacher, he liked to call himself as an educator. He was at the heart of his work was an innovator who practiced chemical engineering slightly differently. He's a born leader. He's also a visionary. Many of the policies of the ICT, the erstwhile UICT, was also shaped up by him. He's also an educator to his core. So just one small quote about Mr. Professor Kamath. I do not teach. I am not a teacher. I am not qualified to be a teacher. I am not even competent to be a teacher. I always said that I am an educator. Anyone who would like to be educated, I will help. Anyone who would like to learn, I will help by guiding them. What a power-packed, great vision he has. So today, we are celebrating him, and as somebody said, I'm extremely honored to stand in this podium simply because the predecessors who have spoken about Mr. Kamath are all big, great people. Thank you so much. So, the topic today is Metamorphosis of Coating Industry, a journey towards eco-friendly and sustainable solutions. The topic, I was pondering on a reasonably good topic to present to students. So I thought this is very apt and relevant, And since a lot of students are there, this is future looking. This is for you. We are all talking about the future generation, the coming generation, what we are going to save for them. So I thought this topic is pertinent. That's the reason why I selected this topic. Metamorphosis is a Greek word. Meta is meaning change and morphos meaning form. Okay? What is the relevance of metamorphosis in the coating industry? So, I personally believe that a grind is happening in the paint industry. A grind for good. So, when I talk to many of my erudite industry leaders, many of them say, Krishnaraj, look, there is not a great innovation happened in the paint industry in the last 50 years. Okay. I strongly disagree with them. I still believe that paint industry is going through a paradigm shift. There is a transformation journey which is happening in the paint industry, which is for the good. So metamorphosis in paints and coating refers to the transformative journey of the industry in pursuit of technologies and materials to create more sustainable, eco-friendly and high-performance product. So that is the theme of today's presentation, friends. So I thought, since a lot of students are there in the gathering, I have a responsibility to introduce sustainability before I jump into coatings, because this is a very important topic, and this is something which all of us should understand and assimilate. So let's understand what is sustainability, past, present, and the future. What is sustainability? It's a very heavy definition, but I'll just read out for you. Sustainability is the idea of meeting the needs of present generation without compromising the ability of future generation to meet their own needs while balancing economic growth, environmental care, and social well-being, profit, people, and planet. This seems to be a very power-packed definition, but the fact of the matter is, sustainability isn't just a buzzword. Sustainability is one of the highly Googled words. There are a lot of searches happening on sustainability. But sustainability isn't just a buzzword. It's a pledge to build a brighter future and safeguard the planet for generations to come. Sustainability is all about what we are going to do for our kids. Sustainability is all about what we are going to do for our grandchildren. Hence, this topic is extremely relevant and is extremely close to my heart, at least. So, if you want to deep dive into sustainability a little bit, because it's a very big topic, I'm not going to really spend a lot of time on introducing you. Whatever little time I have, I'll try to give a perspective of sustainability. There are different, perspectives for sustainability. There are 3 P's, there are 3 C's, there are 3 E's, and there are 3 R's. Even though it looks little bit of jargon, it's also very important to understand all these concepts very clearly. So the 3 P's of sustainability are people, planet, and profit. So at the heart of all those things is people. Without people, nothing can happen, right? So the same is the case of sustainability as well. The 3 C's of sustainability are conservation, community, and circular economy. You would have heard about circular economy a lot. You would have read about circular economy. We'll also discuss what is circular economy. The 3 E's of sustainability are economy, ecology, and equity. And the 3 R's of sustainability are reduce, reuse, and recycle, which has become like a slogan nowadays, right? So the 3 crucial components of sustainability which I've alluded. The number one and the most important thing is circularity. We are all striving, when we go this sustainability journey, we are all going to strive towards a circular economy. Circularity involves designing products and systems to minimize waste and make the most of the resources. So one of the cornerstone of sustainability is we don't have infinite resources. Nobody today in this world have infinite resources. We all know that the resources will trickle down. I was just reading the other day about the COP's 28 conference, which has been, the proceedings of the conference which has been concluded in Dubai last year. So the COP's, one of the most important resolution of COPS 28 is to curtail or reduce the fossil fuels, okay, the use of consumption of fossil fuels. It is a great step towards circularity. Circularity also emphasizes the recycling, reusing and re-engineering of regeneration of materials to create a closed loop system. So it's absolutely important for us to understand this circularity because, as I told you, the resources are limited. The Mother Earth don't have as much as we can to consume. The number two and the most, one of the most important point is the preventing the climate changes. Okay. So, as you know, we are all going through very turbulent times as far as climate is concerned. I need not, ponder upon that more because today's heat itself says volumes about the moment rains have stopped, what is the kind of heat is getting generated. So this is a very pertinent topic. This focuses on reducing the greenhouse gas emission. So as all of you know that a lot of greenhouse gases which is made by the industry, especially from the paints, the volatile organic compounds, how we can prevent climate change through the curtailing or restriction of the greenhouse gases. Last but not the least, ensuring health and safety. Health and safety is a very important topic. Today, if you ask me, sustainability is not just a boardroom topic. Once upon a time, sustainability used to be very fashionable and it used to be a topic for the boardroom. But today, I think the industry has itself matured and it's no longer a boardroom topic and it is also no longer a jargon. Today, sustainability is being practiced by letter and spirit by companies. Hence, ensuring health and safety is very important. I've seen many companies walking the talk by even putting health and safety in their KPIs, in their performance appraisals. And if mortality happens, companies deduct the incentives. I've seen various corporates doing that, which is a very good thing because it's ultimate paramount importance that we also consider health and safety of the employees as well. The 3 P's of sustainability, I'll just touch upon this since it's very important. As I told you, the planet, people and profit, climate change, mitigation and adaptation, resource conservation, water, energy, materials, waste reduction and management, biodiversity and ecosystem is consisting in the planet part. As I told you, without people, people is at the heart of the entire initiative of sustainability, human rights and fair labor practices, health and safety, community engagement and development, education and training, diversity, equity and inclusion. And in the profit, financial performance and stability, innovation and competitiveness, market growth and development, cost saving and efficiency, long-term viability and resilience. And what is most important is the 3 P's are interconnected and interdependent. And achieving sustainability requires balancing and integration of these 3 P's. So, one, people, planet, profit, this has to get integrated. Then only the real meaning of sustainability comes. Now, this slide is slightly busy slide, but then I'll spend a minute in explaining. This is a very important slide. So, as I told you, there was a time when sustainability was very fashionable and it was mainly confined to the boardrooms and the ESG reports of companies. The time has changed. There are various benefits of sustainability. I've just jotted down some of the very, very important benefits of sustainability in business. First and foremost, sustainability is today embraced by many companies to enhance brand reputation. There are several examples in front of us, starting from Tesla to Patagonia to IKEA to Apple. You would have heard about Patagonia, which is a apparel company which use 100% recycled materials to make the apparels, t-shirts, clothings. We know Tesla, which focus on sustainability. You go to an IKEA shop in Mumbai, you would feel sustainability there. And Apple, obviously, I need not tell, it's driven by sustainability. Market differentiation, very important. Today, companies do differentiation in the market on account of sustainability. Unilever has done a lot of examples worldwide. In our own India, our own country, Fab India has done a fabulous job in terms of market differentiation using sustainability. Increased innovation is, innovation is at the heart of sustainability, because all this recycling, reuse, all these things require different thought process, and hence innovation is at the heart of sustainability. Better quality of life to our own generation and then the future generation. Reducing carbon footprint. This is a very, very important topic. This is a topic in itself. It requires hours to explain you the real benefit of carbon footprint. Environmental protection, enhanced biodiversity, reduced waste, and taking care of future generations are some of the stark benefits of sustainability. Now coming to the topic of coatings, today's topic. Why sustainability and eco-friendly coatings? First and foremost, resource depletion is going to be a major challenge. Most of you know that paint industry is a highly raw material intensive industry. Most of my friends sitting out here will agree that the industry thrives on raw materials and the supply chain, how materials are coming into this. And the other important point is many of these raw materials are petroleum based, crude based, whether it is the monomers or whether it is solvents. Most of these raw materials are also petroleum based. As we all know, resources are finite. One day this is going to trickle down. So it's absolutely important that we understand this point of resource depletion. Waste generation. Production of paint generates significant amount of waste. Where to throw this waste? Many of the paint companies are grappling on how to reduce the pollution, how to reduce the kind of waste which is getting generated. So we have to have answers for that. Chemical emission and human health. Also many of the paints, solvent-based, especially water-based is better, but solvent-based emit a lot of VOCs, chemical emission, which is harmful to human health. So that also need to be taken care of. How we can curtail the chemical emission. Environmental impact. As I told you, the greenhouse gases which is being liberated during application, film formation, and even in the container can have a very dangerous effect on the environment, and for that matter for the climate change as well. So the journey of Indian paint industry, before I enter into the various elements of coatings, I'll just give you a snapshot on the Indian paint industry journey thus far. In a single slide, it was difficult to paraphrase this, but then this is how I see the journey of the paint industry. In the 1900s, we were talking about distempers, cement paints, and enamel. I still remember when I joined Asian Paints, we were that time, there was no exterior paint per se in that point of time. There was only cement paint. There was very few companies who manufacture emulsion paint. Cement paint came into the forefront in the 1990s and above. So there was an era where all these paints was not there. The paint was largely confined to distempers, cement paints, and enamel. 1980s, emulsion paint came to the forefront. Performance came, better film formation came, better performance came. 2000 was marked by non-toxic lead-free paints. So lead was a major contributor for toxicity in the paints. And thanks to Central Pollution Control Board, CPCB has issued guidelines for all paint manufacturers that lead content should be less than 90 parts per million. And due to that diktat, all the retail paints in India started following, and today most of the paint companies, at least for the organized sector, is having lead content of less than 90 parts per million. Then in the 2010, we started low VOC coatings. So low VOC coatings also, came with its own share of problems, because in those periods, matching the performance without solvents was not an easy job at all. So today we are at low VOC, and in the next slides you will see what is next to VOC. It's all low emission coatings which is driving the market. Just before getting into this nitty-gritties of the our topic today, we are also like to know about the global paint market. Today, the global paint market is a 217 billion US dollar market with a CAGR of 4.5% growth, expected to touch 304 billion US dollars in 2032. And as you can see from this pie chart, the major growth or the volume, almost 50% of that is coming from the decorative segment. There are valid reasons why the decorative paint is booming. It is because of the trend towards a water-based and solvent-less paints. So invariably this decorative market is booming. The other markets like general industrial, powder coating or protective coat are all small pies, less than 10%, except for the general industrial paint, which is 11%. So largely the decorative paint is ruling the roost, if you ask me. Now coming, Indian paint market is sized as 9.56 billion US dollars, which is roughly 75,000 crores, and which is having double digit. Okay, 9.38 I consider 10%. So we are growing almost double digit, which is good news for all of us. So it is poised to grow to 15 billion US dollars by 2029. And as you can see, the major difference here in India is 77% is decorative paints, which means that we are all thriving towards more and more towards decorative paints rather than industrial and automotive paints. Now, coming to the major trends, the mega trends in the sustainability and eco-friendly coatings, which is what I'm going to talk and try to make you understand. So there are number of major trends, mega trends, I would say, in the coating space, which is forward-looking, which is gelling with the entire philosophy of sustainability. I'm going to talk about each one of these 8 trends in detail today. Number one is, first and foremost, the number one trend is low VOC and low emission coatings. So low VOC we touched upon a bit, but then I will explain you what is low VOC and the forward-looking low emission coating. Number two, indoor air purifying coatings, which is also gaining traction. Very important. I'll explain you how it is going to be unfolded. Biocide-free paint. This is an extremely important category, which is going to be the future because there are a lot of consequences of biocides. Non-toxic paints which are very less toxic. There are paints which you can drink. One coat hide paints which require only one single coat, thus reducing the painting cycle. High solid coatings which can just work with one coat. Use of bio-based materials and sustainable manufacturing. So let's solve this jigsaw puzzle of VOC. What is VOC? Most of you may be knowing that, but still a refresher. VOCs are harmful carbon-containing chemical substances that vaporize at room temperature and enter the atmosphere. Okay. They are very volatile. There are numerous health issues of VOC. Breathing difficulties, dizziness, headache, fatigue, and even cancer. Right? But let us understand VOC slightly more granular. Because this is very important, this point. If I make you clear VOC only, I can go to low emission. What is the definition of VOC? There are two definitions of VOC. One is the European definition and one is the US definition. VOC is defined as any organic compound having an initial boiling point less than 250 degrees Celsius as per EU definition. And as per US definition, VOC is any organic compound having an initial boiling point less than 280 degrees Celsius. It is measured by ASTM D6888618. Okay. Now, what are the major contributors towards VOC in the paint? Number one, first and foremost, solvents used in the paint. Glycols, alcohols. Coalescing solvent agents used in the paint. So I started my career in polymers. Okay. So in those good old days, when we characterize a coalescing solvent, the first and foremost thing which we used to do is add same quantity of coalescing solvent in the same polymer and see the reduction in the minimum film forming temperatures. So ultimately, coalescing solvents are added to paint to reduce the minimum forming temperature of the polymer. So again, it contributes toward VOC. Surfactants, all of you know, surfactants are interfacial tension reducing agents, which is absolutely essential for paint stability. Preservatives, I always say it's a necessary evil. We cannot get away without adding preservatives. Preservatives are absolutely important because most of the water-based paints require preservatives. Unreacted monomers, these are free monomers, are available in the system, so this also contributes toward VOC. So if you assess the VOC levels in the paint, there is a body called REACH, Registration, Evaluation, Authorization and Restriction of Chemicals. REACH has a guidelines, okay, how the paints are classified as per VOC. So about 250 grams per liter is known as very high VOC, which is also like enamels and lacquers, which have very high VOC, about 250. The VOC level of 100 to 249 is termed as high. 50 to 99 is moderate, and 5 to 49, less than 50, is low. Typically the flat paints, the matte paints belong to this, and less than 5 grams per liter is very, very low VOC. We can almost consider it as low VOC. So different countries have different regulations. Even though in India we don't have regulations, but most of the countries have regulations and they have standards. In US it is ruled by the Green Seal GS11. It talks about less than 50 grams per liter. In China, the famous JG, which is very stringent, which is less than 20 grams per liter. Singapore, Malaysia, Thailand, all the Southeast Asia countries follow a common eco-labeling scheme. Even though Singapore, it is slightly strict. Singapore says that it is less than 25 grams per liter. Australia is a very, very stringent standard. The Australian Eco-Label Program, also known as JECA, is having a VOC level less than 16 grams per liter. Philippines, likewise, and France have a standard. And Europe is the torch bearer of sustainability. I have a separate slide at the end of my presentation about the initiatives which European countries have taken, which is a real model for all of us. So Europe has the highest, the best regulation and the most stringent VOC norm, which is less than 5 grams per liter. So there are various bodies which actually certifies and guide this, green labeling. The Blue Angel of the Germany. Blue Angels of the Germany is very famous and very stringent. French A+ VOC, Singapore Green Label VOC, the Australian Eco Label, the New Zealand Eco Labeling Trust. All these are important bodies for green labels. Now coming to the most important topic of this is a corollary to VOC, and this is the most important and the latest forward-looking trend in VOC. This is the low emission coating. So we talked about VOC thus far, but what is low emission? Low emission is a step ahead of low VOC. In low VOC coatings, we talk about the VOC content in the paint, in the can. Low emission coating talk about VOC in the can plus VOC when it is applied on the substrate, the vapors which come when it is applied. So it is much more stringent and more holistic. It actually talk about a very important area in paints where we can reduce the VOCs and then have a very low emission coatings. So low emission coatings talk about TVOC. That is the total VOC. So VOC plus VOC in the can plus VOC which is emitted when it is applied. So that is the TVOC or the total VOC. So the limits prescribed is less than detectable limits is 0.1 to 0.2 grams per liter. So our VOC limits were 5 grams per liter for low VOC. Here we are talking about less than 0.1 to 0.2 grams per liter. There are some standards. This is an evolving area. There is no much literature available. Some of the very few countries practices, and there are very few manufacturers who can give this kind of additives or raw materials to make low emission coatings today. So EU Eco Label talks about 200 micrograms per meter cube. Green Guard Gold talk about 220 microgram per meter cube. And there is also this California Air Research Board, CARB, which also talks about a very stringent standard of low emission coatings. Coming to the formulation technologies for this low emission coatings, we need to be mindful about the organic solvents which is being used. And there are technologies available today to make low emission coatings which is based on the polymer binder, very low MF50 without compromising on the performance of the polymers, of the paint. And the unit of measurements is milligrams per liter for this emissions. So to summarize this, topic, health and ecology benefits of low emission coatings. Number one, it reduces the carbon footprint. The greenhouse gases are being curtailed because of this. Improved air quality. The air quality can be really improved with low VOC, low emission coating. Sustainable manufacturing, because many of the raw materials used are renewable. So it's also is igniting the manufacturing, sustainable manufacturing practices. Reduce health risk. Low odor. This is very important because today, one of the surveys which I was reading the other day, one of the most important reason why people don't paint their house is because the hassles associated with painting. And one of the most important hassle for painting is nothing other than the odor emit when you paint a confined room. So if you are able to eliminate the odor of the paint, that is going to be a great value proposition for both the consumers and for the painters. But while talking about odor, I have a short story to tell you. You know, way back one decade before, I was working on a very low VOC, very low odor paint. So we developed that product and we did trial in Rajasthan. And while doing the trial, the painters, I was asking the painter that how do you find the paint? Okay, it was very low odor, which was I myself was perceiving and my colleague was also perceiving and the house owner was also perceiving. But the painter told that, look sir, this is not the original paint. So I was zapped. I asked him what is the problem. So he told no, it don't have the typical paint smell. And hence this is not the original paint. You have brought a duplicate paint. So you have to understand this mindset while developing low VOC products. So we are coming with a very standard framework of mind, which is also true to sustainability, because to change that mindset of people is not going to be easy. There's a lot of work which has to go behind that. But still, it's worth trying that because that is the future. The next topic on this major trend is indoor air purifying coatings. So how many of you know that indoor air pollutants kill more than exterior air pollutants? There's a I was under the impression some 10 years before that exterior air pollutants kill more than interior air pollutants. That was my perception at least. But then I corrected myself because a lot of researchers says otherwise. We spend a staggering 90% of our time indoor. Post-COVID, you know, there was many people working from home. There are a lot of co-work space available today, which are all, you know, in the confines of the walls. So staggering 90% spend, time indoor. The Environment Protection Agency, EPA, and other groups acknowledge that indoor air quality is on an average 5 times worse than outdoor air quality, which is glaring, right? You know, the air quality in indoor, which we think that is very good, my home is same, is not correct. As per EPA, 87% of the population are facing ill consequences on their health and well-being because of the indoor air pollution. As per WHO, World Health Organization, about 4.3 million deaths each year are associated with indoor air pollutions, while 3.7 million deaths a year is reported for outdoor air pollution. Hence, indoor air pollution kills more than exterior air pollution. So I was reminded about Delhi when I was preparing this slide. I was thinking why so many people complain in Delhi when winter sets in about exterior air pollution and nobody is complaining about interior air pollution. Just food for thought. So number of deaths by risk factor. So this is just a statistics. This is just a slide I took from a website which is authentic. High blood pressure, smoking, high blood sugar kills the most. The fourth one is air pollution, both interior and exterior. So this is a very glaring statistic just to remind you that it's not very, very safe even in your home. Okay? So the heart of all these pollutions are this, all these materials which I have listed out. Formaldehyde obviously tops the chart. Formaldehyde is a very, very dangerous material, and you will find formaldehyde everywhere in your room, starting from carpets to your wood finishes to your curtains. So you mark this material, formaldehyde. Particle board, plywood, urea, formaldehyde, tobacco, smoking, furniture, everywhere you name it, it is there. And starting from headache to cancer, it can cause so many ailments. Other VOCs like paints, solvents, wood preservatives, aerosol sprays, VOCs are being emitted. SOx, NOx, carbon monoxide, combustion of fuel in the kitchen, you will find it. Even when you burn a candle, you will have this. Particulate matter obviously will come from tobacco smoking. Pesticides, it is there in the home when you do a heat also, it's a pesticide. So moth repellents, insecticides. Biological pollution, your interior potteries, you have a flower pot in your home, the pollens, wet and moist walls, even paint, moist walls is not good. This can cause problems to you. So this slide is a very interesting slide. So you have 8 pollutants, at least I have listed 8 pollutants, there could be more, but 8 pollutants in home, the very home which we are all living. For example, the furniture can emit a lot of melamine formaldehyde. Most of the furniture are coated with melamine formaldehyde or urea formaldehyde resins. Furniture's formaldehyde is emitted. Carpet also contain formaldehyde. Candles, as I told you. House painting. The paint also emit a lot of formaldehyde. In the good old days, the best biocide was formaldehyde. All of us know that formaldehyde is a good preservative. Okay, so we used to add a lot of formaldehyde in the paint in the olden days, but thanks to the new technologies, now formaldehyde is gradually dwindling, at least in the paint. But there are other biocides which I will come to the next slide. Cigarettes are there. Asbestos is very dangerous, as all of you know. Even the detergent cleans and air fresheners is also not good, because a lot of air fresheners also contain a lot of VOCs, which are not VOCs and CFCs, which are not good for the health. So I just want to spend a minute on formaldehyde because this is very important. Formaldehyde is the most important pollutant and killer as far as we know. Formaldehyde is the most carcinogenic pollutant in the indoor atmosphere. Its levels in indoor air can range from 0.01 to 10 ppm. The average person is exposed to 0.1 to 0.1 ppm formaldehyde in indoor space. And exposure to formaldehyde can also cause eye irritation, nose, throat, and skin, apart from the cancerous dimension which I have talked about. The annual death estimated is 10,000 to 20,000 deaths globally, which actually mortality rate in the US, if you see, is 1.4 to 2.8 deaths per million people per year, which is also glaring. So what is that coatings can do to mitigate all this risk? So there is a type of coating itself called air purifying coatings. And what are the technologies used to mitigate this risk? Photocatalysis is one of the most important technology used for nano TiO2s, which are used, which when reacted with oxygen species breaks down the pollution into harmless compounds. There is also the activated carbon technology, which is like a filter. As you know, activated carbons are good filters, so it can filter the odors and VOCs from the paint. Formaldehyde scavenging technologies are available, like there are some of the polymers are available which can actually double as a formaldehyde scavenger. We have the odor neutralizing technologies, like we can have some refreshing odors, refreshing smells, and also molecular sieve technology, and sodium bicarbonate is also at times used as a odor neutralizer. So World Health Organizations has also given certain bodies responsibility to certify certain coatings and certain spaces based on the certain standards for having a safe indoor this thing. This one I found very interesting, the asthma and allergy friendly certification body in the US. They also have a certification program where they certify your product as asthma and allergy friendly coatings. There is the Asthma and Allergy Institute in Denmark. We have the Green Guard. We have the Green Label Singapore. All these bodies also, the Green Portable Certification Program, they also certify indoor air quality and gives certifications which can also be used for branding your products. Coming to the third mega trend, which is biocide-free paint. So as I told you in the beginning of this slide, that biocide is a necessary evil, you know. At least in a tropical country like India, where the climate changes as different from Kanyakumari to Kashmir, you ought to add biocide, because otherwise your paint will not survive. We need to figure out a way out of it. But let me focus on this slide. Let me make you understand what are the biocides going into the paint. First and foremost, there is the in-can biocides, which is to protect the paint itself in the container, because many times we also see that when water-based paints are stored for many long time, you know, you also get some foul odor in that. So preservatives to keep bacteria away from the paint can, preventing contamination from water, the poor quality of water used for diluting the paint, so that can also have problems. Preservation during storage and transport. Then comes the dry film preservation. The dry film preservation is after the paint is applied on the wall. So the in-can is mainly in the container. Once the paint is applied on the wall, another set of problems crops up. For example, interior paint, you have fungus, black blocks and black spots which you see. Interior problem, the green algae which comes. So, we need to mitigate the mildews and fungus and algae of the coatings. So for that reason, we need to add dry film preservation. Then we have the third, this thing is a keep kill. For instance, during transportation, you also encounter a sudden fouling of the paint because of the usage of some spoiled water or some atmospheric conditions. You need to quickly kill the bacteria in the paint. You need to add a dose of that bacteria, decimeter, and you have this quick kill which is readily available. So there are three broad classification of biocide in the paint, and none of this is good for us. So health and environmental effects of biocides used in the paint. So this is a cauldron of toxicity, I would say, each and every biocide. The BIT and MIT, which we use, which are the in-can preservatives, both are very toxic to aquatic life and even to animals and human beings. The diuron, which is used as a film preservative, I told. Diuron is mainly used to kill the algae and the algae in the exterior paints. So diuron is a hot topic today. I'm not sure how much time diuron will be there in the Indian market. Many of the countries are already banned diuron. So diuron, we need to find alternates to diuron. It is a potential carcinogenic material. ZPT, which is also known as zinc pyrothene. ZPT is widely used biocide. It is used in the shampoo industry. It is used in the paint industry extensively. So it is a very toxic material, but still we are using that. There is no alternate for this. So we need to understand how we can have alternate for this. We also have IPBC, which is also added in the paint. But you know, one thing is very clear. We are also dependent on all this biocide, because biocide also serve one purpose. Biocide also prevents the spoilage of the paint. Biocide also, prevent the spoilage of the paint once it is applied. So in that way, biocides are also serving a particular section of the people, and they are doing their job. But at the same time, what is important as far as sustainability is concerned is finding alternates to all these materials which can cause a problem to the human health. So presenting to you the biocide-free paints. So we have technologies today available which are without any biocide. And one of the most important coating which is without biocide is lime-based coatings. Lime, most of you know, apna chuna. it is coming back. Okay. In a much better way, probably. Okay. So that's what nature gives back, right? So, you need to understand that lime also is a very versatile coating. It is having a lot of breathability. It is also having a lot of health benefits. So there is no harm in re-exploring lime. So lime is a very good alternative to biocide-free paint. Why? Because the pH of lime is always higher. It is more than 10. So, normally all the biocides will get killed. Sorry, all the microbes will get killed beyond 10. So, lime is a very good alternate. High pH emulsion paints. So, these are paints where, we can keep the pH deliberately at a higher rate so that no biocide thrive on this. So, no microbes thrive on this. But the only trick is that the polymer emulsion which you are going to use should have a compatibility at a very high pH. So that is one thing which is very important. We have silicate paints, which are those paints which are made out of silicons, and they are a very good alternate because their pH is also high. The only challenge is, you need to understand the stability of the paint and also the recoatability and all other aspects of the paint. Coming to our fourth major mega trend, which is non-toxic paints. So the toxicity of the paint is a highly discussed topic. Okay, there are many components of toxicity of the paint, starting from the heavy metals like lead, mercury, cadmium, solvents, toluene, xylene, benzene, ethyl acetate. We use a lot of pigments which are chrome-based, chrome yellows, which contain poisonous pigments, elements, heavy metals, cadmium sulfates, cobalt blue. All these have problems. All of us know that. Other toxic elements include the APO-free materials, the phthalates which you use as plasticizers, silica, and even free monomers and isocyanates. And the preservatives and biocides which I already talked about. All these are all contributing toward the toxicity of the paint. One particular toxin which I would say is the lead, which is very, very dangerous to human health and in fact animal health also. So lead can cause various neurological damages. It is absolutely not recommended for pregnant ladies because it can also affect the fetus. It can also have a lot of environmental impact like soil and water contamination, air pollution, impact on animals like neurological effects and very, very stark reproductive issues. So in India, as I told you in the beginning, as per the Central Pollution Control Board, the lead content is being regulated to less than 90 parts per million. Okay, so that's a great respite for all of us. Coming to the alkyl phenol ethoxylate, this is a known topic to all of us. The alkyl phenol ethoxylates are very, very toxic material. It is an endocrine disruptor and it can have a lot of negative impact on the human health and aquatic animals because it is also a known aquatic toxic material. So whenever surfactants is used in the paint or in any other industry with alkyl phenol ethoxylate, if it is washed in effluent into the water, it can potentially damage the ecosystem and the marine or the aquatic animals. So to summarize, the impact of toxic elements are, environmental pollution, eye damage, neurological issues, cancer, respiratory problems, and skin irritation. But what is alternate to non-toxic paints? I happened to see this paint, this milk paint. It's a very, very interesting paint. What they claim, milk paint is a natural paint option made with milk proteins, casein, lime, and pigments. It's non-toxic, biodegradable, and low in VOC. So much so that the manufacturer says that one coat of paint and one sip of paint. Okay, so that's a very interesting concept, and the performance is also not that bad, as we expected that there is no binding. It's not like that. There is minimum performance guarantees. So this is an area where we need to ponder and we need to develop. Clay paint. Clay paint is a very interesting concept. Clay is completely natural. Clay also has a lot of, once the clay paint is made, it is also porous. So there is a lot of breathability in the clay paint. Lime paint, as I told you, we are going back to basics. It is one of the most interesting concept, very, very sustainable, and it is also durable also. Okay, so there is no problem with the durability. Some of the lime paints are also applied in the exterior. All of you know that exterior paint require a lot of performance. There is a soya-based paints which is based on the soybean feedstock, which is completely sustainable, and hence all these options are actually eye-openers, and all these points are something which we all need to ponder. Coming to the fifth topic, which is the one-coat emulsion paint. This is a category which I myself has worked for many years. So one-coat height paint is a topic which is close to my heart. This is the paint system which can cover and hide underlining surface with a single coat. One coat, khatam, that's it. So that is something which we should aspire. There are a lot of a plethora of benefits of one-coat emulsion paints. First and foremost, reduce material usage. So there itself it is sustainable. Means we are preventing consumption. Okay, the point which I told you in the beginning of my lecture, that we need to curtail our resources. Okay. Reduce material usage. Fewer coats means less paint needed. Waste reduction. Fewer coat means less wastage. Instead of 2 coats driven by the painter, only 1 coat. So that much less wastage. Water conservation, very important. This is double whammy, because one is it is only 1 coat. Second is one-coat emulsion paint doesn't require dilution. It is ready to use. For instance, one-coat emulsion paint is very popular in the US and in the Western countries because the labor is very expensive. So generally the house is painted by the house owner. Okay. So unlike India where we have a painter in between. So one-coat emulsion paint is, require no dilution simply because the house owner is going to paint the house. He don't want the hassle of diluting and stirring and applying on. So he wants ready-made. So it is very interesting. Water conservation, transportation efficiency, lower paint volume result in more efficient transportation and reducing the carbon footprint again by reducing. Less packaging, less paint, less packaging. Energy saving, reduced application time, and coat means less energy required for painting. So one coat is a very win-win situation, but I will tell you the other side of it since I have worked in this. I have been working on one-coat emulsion paints for so many years, okay. I have not successful, let me tell it very upfront. The reason is we have somebody called painter in between, right? So in India, if we come with a one-coat emulsion paint and we try to convince painter, I don't think he will readily agree because his labor is lost. His second coat is lost, right? So that's a challenge which we need to understand while developing one coat. But there are ways and means to really convince the painter also, I strongly believe. So this is a win-win proposition and we should try to promote this. Various technologies used by for developing one-coat emulsion paints. The first and foremost is the rheology modifications. The right selection of thickener combination for maximum film build-up. Optimization of thickness to get the best flow and leveling. Okay. Polymer design, very crucial. Customized high solid polymers for enhanced binder performance. Wetting and dispersing agent, which is very crucial for one-coat emulsion paint. The high solid paints, which is the sixth topic, very important. You would have heard about powder coating, where 100% solid coatings, which is only there in the industrial side. One day, 100% solid decorative paints will be there in India, where we can just go to a Kirana store and just take one packet of powder paint and dilute it and apply. So that should be the concept. So when we have to thrive for that, today we have polymers which are 100% solid, but no decorative paint which is really 100% solid. So high solid paints contain a high percentage of solids and lower solvents. They emit fewer VOCs during application and drying. This contributes to better air quality and reduce environmental pollution. Future can be 100% solids like powder coating. So the benefit of sustainability in high solid paint is, better coverage of the paint. Better coverage because on account of the high solid paint have better coverage. Lower waste disposal, there is absolutely no waste or minimal waste which need to be disposed. Regulatory compliance, most of the high solid paints at least meet or exceed the regulatory compliances. When it comes to the use of bio-based materials, there are a lot of bio-based polymers available today. I am very happy to note that, I interact with a lot of vendors. Some of the vendor friends are here right in front of me. So many of them are also trying to bring to us. So bio-based material is the right solution. This is the path which we need to travel. Natural solvents and binders, solvents which can be from the plant origins, from the non-fossil fuel origin. Because as I told you, petroleum is going to dry up. So coating industry is highly dependent on petroleum, so we need to find out a way for this. Green additive, bio-based additive which can replace fossil-based materials. Recyclable and renewable feedstocks, this is also equally important. So green additives in paints can be in a plethora of areas. For instance, green deformers based on renewable raw materials, natural oil-based film forming agents, highly efficient VOC-free regulatory rheology modifiers, renewable dispersing agents, and natural oil-based biocides, which is also very important. So this is the slide which I was referring to on the green initiative by Europe. I was really impressed by the way Europe has embraced sustainability. So 66% customers who are spending on sustainable product. 73% of millennials who spend more on sustainable products in Europe. Products with renewable raw materials are in demand in Europe. Transform EU into a first carbon neutral and circular continent by 2050. What a great resolve. I really appreciate this. And this is what we should strive for us, Asia or India, to also become. My last topic of this today is this sustainable manufacturing, which is also about efficient milling and dispersion. Because as I told you, the coating industry is a highly energy intensive industry where there is a lot of grinding, mixing, milling. So it is a very energy intensive industry. We should try to reduce that energy consumption. Innovation like rapid recirculation, vacuum milling, and inline dispersion allow for more efficient dispersions. So this is something which you should tap and we should embrace. High efficiency spray nozzles, which also utilize high efficiency spray nozzle for cleaning, which can reduce the wash water. Clean loop wash water systems, implement clean, closed loop water system to allow better water usage, and advanced process control systems. Recyclable packaging is very, very important, and a lot of work has to be done on this. Organizations use containers made with up to 25% recycled plastics. There are programs which focus on recyclable paint containers, where they talk about an intermediate who can recycle the containers and give back to the paint manufacturers. Some of the companies also use flexible packaging, which are weightless and which are less weight and which is easy to handle. Aluminum cans are highly recyclable. This is a very, very important topic. In fact, Aditya Birla has a company called Novalis in the US, which is leaders in the, aluminum packaging. And aluminum is a highly sustainable material. And 70% of all aluminum cans are recyclable globally. Okay? And some of the companies are also working on coatings for packaging which are sustainable. So friends, that was all about the recent trend. Okay, there is only 2 more slides for you. And what is next? What is next for us? So, we strongly believe that can come less, that's okay. But let's not paint again, but let the coating be self-cleaning. Adaptive coatings and biologically inspired coatings. So friends, that takes me to the end of the presentation. So while concluding this presentation, there is none other than George Bernard Shaw who has paraphrased sustainability better than anybody else. He says that we are made wise not by the recollection of our past, but by the responsibilities of our future. Thank you so much. I'm deeply indebted to Color Society for giving me this opportunity, and I'm highly appreciative of the audience who's been very patient and supportive all through. Thank you so much.
Thank you, sir, for this insightful lecture. Your expertise is truly inspiring. Let us now proceed further to the felicitation of diploma students of the Color Society and Shri Mukund R. Hulyalkar Scholarship. I invite Mr. Dilip Patil, Educational Chairman of the Color Society, on the dais. Any questions from the audience?
Carcinogenic, and TiO2 is not allowed to be used in the paint. So for such that awareness coming to India and finding the alternative for such a material which is not as per compliance of European standard, how as a Indian scientist we can work on the alternative for TiO2 and all this, like lead-free paint we are now working, but TiO2 is a next challenge for replacement for TiO2. Since
It's not only a dangerous material, but the industry also is very polluting. Okay. So to that extent, it is not sustainable. Correct, correct. It is very energy intensive and very polluting industry. That's the reason why many of the TiO2 manufacturers are getting closed. So to answer your question, as on today, there is no concrete replacement for TiO2 which is available because of the wet opacity of the TiO2 which is getting. But then there are lot of ways in which we can come through this, because many of the polymers today, okay, the opaque polymers today can also be used to substitute TiO2, and many of the industry has used that, and some of the extenders which are promising, which can also be used, but there is no concrete, it's a divided opinion. Okay, so it is not conclusively proved that still TiO2 is carcinogenic. So that is the reason why it is not completely banned.
Any other questions from the audience? I request Mr. Krishnaraj K to felicitate the following rankers in paint technology. We have Mr. Krishnakant Lande standing first. Next, we have Mr. Vinod Lavange standing second. Mr. Samir Sheikh standing third. In ink technology, we have Mr. Mahesh Kovalekar standing first. I request Dr. Prashant Samant to felicitate Mr. Mahesh Kovalekar. I would like to call upon stage Malika Salunke to felicitate Mr. Ajit Bodhaye, who is standing second. I request Dr. Tipanna to felicitate Ms. Madhavi Patil, standing third. I now request Mr. Mukund Hulalkar on dais. Following students are the awardees of Shri Scholarship. I request Mr. Deshmukh to felicitate Mr. Sanket Ramdas Bangar from TIP Pune. I request Mr. Deshmukh to felicitate Mr. Gajanan Mahadev Benke from Garwari Institute. I request Mr. Dilip Patil to felicitate Ms. Kajal Suresh Hogre from UICT Jalgaon.
Good evening. Good evening, ladies and gentlemen. It is my great pleasure to present the vote of thanks today on behalf of the Color Society. I would like to thank each and every one of you for attending the late Professor N.R. Kamath Memorial Lecture 2024 on Metamorphosis of Coating Industry, a journey towards eco-friendly and sustainable solutions by Mr. Krishnaraj K, Assistant Vice President, Birla Opus Paints, Aditya Birla Group. Thank you very much, Krishnaraj, for accepting our invitations and delivering this excellent lecture on very important topic. I would like to request the Color Society President, Mr. Shivaji Durgal, to present memento to Mr. Krishnaraj. I would like to thank to Professor Dr. S.T. Maske, HOD Department of Polymer and Surface Engineering, ICT Mumbai, for allowing the Color Society to use their premises to carry out our activities. I would also like thanks to Professor A.B. Pandit, Vice Chancellor, ICT Mumbai, for allowing us to conduct the late Professor N.R. Kamath Memorial Lecture in this auditorium. And we are thankful to Honorable President of the Color Society, Shivaji Durgale, and Honorable Secretary, Dr. Prakash Anna Manor for helping us
for organize this event. Lastly, I would like to thank all of our honorable representatives for different associations, our ink and paint diploma students, and all attendees as well as Color Society staff present here for attending this esteemed event and helping us make it success year after year. Thank you. There is one announcement. Diploma courses admission started. Online lecture will start from 15 August 2024. And second one is the Color Society annual seminar will be on 16th and 17th January 2025 at Faryaz Hotel, Lonavala. Please block the dates. Now, this is the time for a group photo. Thank you.